Hey guys, so today I'm going to talk about two collections, collection objects. One is ArrayList and second is HashMap, and we would focus towards understanding how we will make use of these collections. Uh, in my opinion, these two collections, like ArrayList and HashMap, these two collections are kind of widely used across various programming, methods and solutions. Uh, However, I shouldn't be saying that because it really depends on what kind of problem statement you have in hand, and depending on that problem statement, you're going to choose what collection is best for you. So it really depends on what you wish to do with that data. So maybe you have to search something in that data, you have to modify the values at runtime in that specific data structure. It depends on all these factors on what collection you should be using. But for if you want to start with collections, you want to understand how that works, maybe ArrayList and HashMap is like the best way to do that. So I'm going to talk about ArrayList and HashMap, and in that I'm going to talk about how to insert, add values there, how to get values out of there, and how to iterate these collections. These are the basic things I'm going to talk about, because we are going to use these things in our automation framework which we are currently developing, right? So to start with, I'm going to talk first about ArrayList. So let me start with it. So first of all, I will create a ArrayList object here. Then I'm going to enter the type, what kind of values I'm going to put inside this array list. So this you see these brackets, and what is inside this is called as generics, right? So this is introduced in, I think, Java version 1.6 or I think 1.5, and since then this is being actively used in collections to notify at the compile time that what kind of data this array list or object is going to have, right? So let me create the complete list here, collection here, right? So this is an array list which would contain the odd type as string, right? Now this is not mandatory, so if I remove this, it can still hold the data, but since I haven't kind of determined what kind of data this list would have, it could have anything. So I could write list.add, and I can write here a string. Then I could write list.add. I can write here a boolean. It would accept it, and .add. And I can write here 2. That is an integer. So it is accepting everything in this case, right? Now this is not considered to be good strategy, because it might not give you error during compile time, but when you at runtime, when you're trying to do some operations on it, so at runtime this will cause an error. So for example, you want to add something. So if you try to add these values, it might start giving you errors, right? So we need to avoid runtime hiccups by making things right during the writing of the code, or maybe before compile time, right? So by putting in this generic, I'm kind of ensuring that this array list should always have a type as, or the element which I could put this inside this list is always has to be a string. So this generic is a means to do that, like imposing what kind of data I could actually put inside this, right? So since I can only do this, I will have to make everything as string, right? So this is how basically you can add values to this array list. Now how will you know what is being added here? All I would do is just come out this, then list.toString. Come on, toString, right? If I run this program now, you would see that the data you have inside this is being printed here: Akash, Sumit, and Amit. Now this is coming as inside these square brackets. Why? Because this toString has been overridden. If I go inside this, it will take me to the implementation here of toString, and this toString, if you notice here, this is being overridden. So this is an original you can say method present inside object, which is the parent of all the classes in Java, and this collection interface and the collection library which we have in Java actually overrides this and writes its implementation, and it actually its use is to print the data when you invoke toString method on this object, right? Why I'm telling you this, because people sometimes get confused that if you apply toString to any object, it should print its content. It's not like that. It is printing its content in this collection case because it's been overridden. Its implementation is there with the collection library. It will not happen out of the box for every object which you might encounter in Java, right? That's the reason I was talking about this. So you see, my collection now has this data, right? Now let me talk about how will you get data out of it, right? So this is an ordered list, right? ArrayList is ordered list. That is, it maintains the order. If you right now, let's say, add another element inside this, git add, let's say, I'm not getting a name, maybe Sumit1 perhaps. Okay. Now if I want to add this, and if I again print it, it will now add it at the bottom, right? So if I right now run it, run as JUnit test, it will add it at the in the last element. How will I get these elements? It's again pretty simple. So if I write list dot get and I type the index here, so this is 0 1 2 3, right? So if I want to print 0 1 2, so if I write 2, it should print me Amit, right? So this is how I can actually retrieve values out of a collection object. So right now, really talking about quite basic things. So list dot get 2, right? This will print me the second element of the list. I assume most of you are actually familiar with this, but just for the people who are not, I'm telling things from quite basic, right? So now it is printing the second element is Amit. So 0, it starts with 0 1, and this is the second element, right? How will we remove the elements from the list? Let me just write some comments here. This is declaration and initialization. And initialization, then here I am printing the whole list. Then here I am adding a new element, added at the bottom, and in the last. Then I'm again printing, that's fine. This is to retrieve element from the list. Right now, this is also done. Now we'll talk about remove the element, right? So if I do talk about removal, I'll write list. Now, by the way, we have many methods available inside this collection which we have here, right? So these are all for adding. So adding doesn't mean that it will always add at the bottom. You can actually choose the index at which you want to add it. So if I talk about this, let's say I want to add an element at third index, right, or second index. So what will happen? The element which you're going to add is going to be added in that index, and all the other elements are going to shift one element down. So by this, what I mean is, let's say I want to insert, right now our sequence is Akash, Sumit, Amit, and Sumit 1. And if I want to inject another element at, let's say 1, maybe after Akash, so I will write here the element name here. I'll write here, let's say Rahul. And now if I print it, now if I do a printing again, it will actually insert it at the bottom. Yeah. So you see, after Akash, it is printing it. So in list, in this collection interface which we have many methods, and these methods are typically available across all the collections which you would encounter. So it includes your linked list, it includes your vector set, right? So these are kind of methods are available because they actually essentially all extends or implement the same interfaces or abstract classes or classes, right? So this is pretty much how you will add it. How you will get it is also have covered. By the way, if you have, let's say, a list which you want to add, for example, this is list 1, and let's say you have another list. Let's say you have another list, add another list, or you can say merge two lists. Merge two lists. So let's say you have another list. I'll name it as list 1, and let's say here I am writing Akash 1, Sumit 1, and Amit 1. Right? And let's say you want to add this list or merge this list with this list, right? And add that to at a specific index. So that again you can do. I can write here list dot add, and you can use add all.
I didn't catch that. Could you try again?
Sorry. So I can do add all, and here I can actually write the index at which I want to add this. Let's say I'm writing here 2, and I write here list 1. Right? Now if I print it, it will actually add it there at that specific index. So let me run it again. So you see, I'm adding these elements here. So these elements are being added at index. Something is not quite adding up. Let me check. So I suggested this to be added inside list. Oh, my bad. So actually this is list 1, and actually this should be list 1 also, because it's a new list which I'm creating. And if I just run it again, so yeah, now it is adding it to the index after index 2, right? So it is adding here Akash 1, Sumit 1, Amit 1, and then the other. So all these elements which were there before, so previously it was this, and now these all were shifted three towards right, and then I have new list being added here, right? So this is how you can merge two lists. Now, lastly, I'm going to talk about iteration. By the way, if I go and check, give you some more view on what are the methods available. So we have addition. You can check the contains. So contains is also a very good method which is available, where you can check whether list contains a specific element or not, right? So that also is available for validation or for searching purposes, right? Now there are a few more things like for each. This is like in Java 8. This is where you can actually use lambda expression for iterating, within all the elements of that collection. I'm not going to talk about it as of now, because this really comes into somewhat, I should say, advanced thing. I'm just talking about very basic stuff here. By the way, you can also use last index of. Now this is used when you want to, fetch the index of a element. So you can pass there Amit, and it will give you at what index that specific string is present. So all these things can be used, and we have removes, right? You can use remove for removing that an element. Replace all these elements are there. All these methods are available. You can get the sublist out of a list. For example, you want to get only specific area of that list. Like you have a list of where you have 10 elements, and you want to get a sublist where you want to fetch list item from index 4 till 8. So it will give you another list where you will have index all the elements which is coming from 4 to 8. Right. So all these methods are there. Then you have you have an option to convert into the native arrays. Right. So Java also have a concept of arrays within itself. You can actually get your collection to be, or ArrayList to be converted to an array using these methods. Now let me talk about iteration, right? So because this is something which is very, very useful, and you actually have to do it a lot in your automation framework. So I'm going to talk about it. List dot. So there are multiple ways to iterate it, right? So if I talk about very simple one, it's a for loop. For int I. This is like very, very basic fundamental way of looping through and collection. So I'll write int I equal to 0. Then I'll write here list dot size. This will give me the how many elements we have there, and then I'll loop it, enhance this counter, increment this counter for each iteration, right? And then I can start getting it. So I can write here sys out. Then I can write here list dot get. As you know, get is used for getting the value. So I'll write here get index. Now this will give me, for each iteration, it will go and check for iteration I as 0. It will give me the first element. Then next iteration 1. It will give me the second element. Then iteration I will be 2, then it will give me the third element, right? So maybe I'll run it again, and it will print everything. See, for every iteration it is printing it. Now this is one way of iterating, right? Iteration maybe method 1. Now, another way of iteration is using iterator. So sorry, iterator method 2. So what I'll do is I'll create an object of type iterator. So I'll write iterator itr is equal to list dot. Now list dot, if I do, I have another method called as iterator, right? Now this method actually is used for iteration purposes of any collection object which you want to use. So this is available across all the collection which you might see. I'm going to use this one. So what this returns me is an iterator interface, and then I'm going to use this like this. So I'll use a while loop. I'll write here itr dot, and I will write here hasNext, right? So this hasNext means it will iterate until the element is available inside the list. Iterate.hasNext, and then if I go and print it or print all the values out again, I'll write here itr dot next. Now this will give me the access to the element present inside that list. I'm also right here looping to use iterator so that it gets distinguished. So if I run this again, so now all these being iterated using this second method, right? So this is how you can iterate this array list as well. Now other than that, let me tell you about one more concept. So how about creating an array list which is a collection of another array list? So like I'm talking about two-dimensional array list, how will you actually create it? This also is a very important concept, and it's being used in various problem statements, solving various problem statements, even in automation. So when you have two-dimensional data, you will have to create something called as two-dimensional data structure or a collection. So let me first tell you in what cases you might have to use it. So if I say public void S02 multi-dimensional array list. Okay, so let's say we have a situation wherein we have to save data like this. Let's see this data 1, 2, 3, 4, 5, 6. Now this is at one-dimensional data, right? That means each data can be saved inside a cell or inside an element. Now what if you want to save a data something like this? So you want to save something like this 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Now this surely is a two-dimensional data. You cannot save it in a single cell, right? So for this actually goes like this will be a first value. So this will act as a row and column, right? When you have two dimension means you have rows and columns, and to save this kind of data you have to design a two-dimensional data structure. So to do that, what I'll do, let me show you how that's done. So let's say I want to save this inside a two-dimensional array list. So how will I create it? Let's talk about that first. So I create an array list. I will say, let's say it will save string. I will say so let's say these are columns. So I'll write here columns, column list, then new array list, and I write here string. So idea here, the way I'm designing this is that in this array, I'm going to save these values, right? So I'm going to save first, second, and third, right? This is a row. So I'm going to save 0th column, first column, and third column data inside this of the first row, right? So for this, I created this particular collection, right? Particular object. So I'm writing here something like this also. Like I write here something like this is data for row 1. So I'm right now statically putting data inside. It's not a dynamic, so I'm statically putting it. So if I put it like this, dot get 0 is 1, then I will say, sorry, not get. I'm sorry. This is supposed to be dot add 1, and I'll add few more. What's happening? Okay. This is supposed to be an integer. I'm supposed to be adding integers in this, right? Let me integer dot add 1, right? Or rather, let me start with 0. It would be fun, right? So let me start with 0. Let's suppose that this array list is something like this. It is 0, 1, 2, 3, 4, 5, 6, 7, 8. Let's say it's this. So now first 3 elements I have to save in this. So I'll write here 0, 1, 2. Now I have to save this array list inside another array list which points out to the first row. So how will I create that? I'll write here array list. Now this is important. This is what I wanted to tell you guys. So inside this array list, I need to add another list. So each element of this array list will have another array list, which is this, right? So what I will write here, array list. So usually, if you remember, you used to write here something like string, right, to indicate what kind of element is going to be present inside this array list. Now in this array list, which I am right now creating, in this array list, I will give it a name as row. I'm going to write new array list. I'm leaving this like this, right? So I want to create this kind of array list. Inside this array list, I want to add, in each element, I want to add another array list, right? So I need to actually mention it inside these brackets. What kind of element each element of this would hold. What kind of object each element of this array list would hold, right? That I have to mention. So inside this, I will write that I am going to add another array list, which is of the type string, right? And this is how actually I create 2-dimensional array list. And I have to do similar thing here. So inside this, I'm adding another array list. So now I can actually have an option to say row dot add, and inside this add, I can add an object of another array list type, right? So I will do this. Now this becomes my row 1. All right, underscore 1. Some error coming. Let's see what it is. Actually, it is supposed to be an integer. Let me add a integer type here, right? So my row 1 data is now saved here. How can I prove it? If I go and run this, run as JUnit test. Sorry, same, executed again. I am supposed to be running this test. So if I, not this one. Okay, I'm not printing anything, so that's why it says out. If I go and print row 1 here, row 1.to string. If I run this now, so you see, this is the first element of the parent array list, right? Now let me show you, let me add more values to it. So for adding these values, I will have to create another collection. So if I am marking it as one, I need to create another one. Right now, see, I'm very statically creating this data. Usually this is not being done. In reality, you actually have to iterate and add these kind of data in a for loop. Right now, since I am statically adding it, so I have to create all these objects by hand. Otherwise, these can be generated at runtime in the using a for loop. So if I now add another data, if I add here, add second row, this was add first row, right? Right here, 2-dimensional. So here, if I create something like this again, so if I do this, 2, so I will create here. I write here 3. Right here 3, 4, and 5. Right. So I've added it here, and then in the same object. So this was supposed to be actually the parent one. So if I say parent, and inside the parent, I'm going to go add print.add and the second row. Second row here, right? So now you will see what will happen. Okay. So if I go and structure it properly, so first up, what I will do is I will declare a parent first. So I will write here, let me restructure it properly. If I write here like this, declare or init a parent collection. This will be my parent collection. Now here I'm adding the first row. I'm creating first row. Here I am adding the first row. Right, then I am adding the second row, or I should write creating the second row and then adding the second row. Right, now if I run this again, see what will happen. So see, now this is my collection, parent array list, and inside this is my first element, first row. Excuse me. This is my first row, and this becomes my second row, right? And same way I can actually keep on scaling this array list for further. So this is how you actually create a 2-dimensional array list. We are going to see a lot of such actual live creation of these objects in when we automate few of the scenarios. I'm going to talk about how to use them and where is the use cases of these collections in those examples. Now next part which I'm going to talk about is HashMap. I'll try to do that quickly for the sake of time. So I'll create another class. I'll give it a name as HashMap example. All right, and I'll click on finish. And here I will write another method. So public void test01 HashMap example. Iterate test. Let me mark it at the rate test as well. Now hash maps are used when you have something like key and value, right? So if you have a data where all the data is associated with a key, let's say we have some data like this, data 1, 2, 3, 4, 5. Now this is single dimensional data, right? Now if we have a data which is associated with some key, for example, I'll write A is 1, B is 2, and C is 3, right? So such kind of data, to store such kind of data, you have to have a associative array, which is also in Java is called as HashMap. How will you create it? Let me tell you quickly. HashMap. Now since it has 2 values, right? So I have to save A as well as I have to save 1. So I have to declare, while declaring I have to mention that it will have 2 elements, and each element's type I have to define as well. So I like here first is integer string, second is integer. Then I'll write here HashMap is equal to new HashMap string comma integer. Right, I have to import this, of course. So let me import this java.util. Now HashMap is completed. How will you add the data? It's pretty simple. hm.put. Come on. hm.put. So this becomes my key. I'll write here a, and the value will be 1. Then hm.put. Maybe I'll just copy paste quickly. This is B, this is C, this is 3, this is 2. And same way I will be able to print it. So I will write here sys out, write here hm.toString. And if I just run it, run as unit test. So it will print like this, right? A equal to 1, B equal to 2, and C equal to 3, right? So each this element has 3 entries, right? And each entry is like has key and value in it, and that's how I'm printing it. Now again in HashMap we have many methods. So if I do hm dot, you will see contains key. You can check at runtime whether a specific key is there or not. So if I want to use this, what I will do, I'll write contains key. I'll put this inside a if condition. If this contains key as B, then sys out key as B is found. Okay, else not found. It's not found, right? So if B is present in the key anywhere, it will actually you can actually find it. So this is like one of the use case of why will you use contains key. If you want to check whether a specific value is present in the key or a value, right? So if you want to check value, you can write hm.contains value, right? Now next item in this would be, let's say hm dot you can actually remove, so all those methods which we talked about in the ArrayList case, you can remove elements, you can replace elements, right? You can merge to HashMap the way we merge things list in the ArrayList, right? Same way, same concept, similar concepts concept present here as well. You can merge two hash maps using put all, right? Put we already have seen how to use it. Then we have contains key, contains value. You can actually very well see how we have used it here. Now last thing in this is, if you want to create dual hash map, right? Now in what circumstances you will have to do that? So let me tell you an example. So if I have a data like this, the data is Akash, physics marks are, Akash physics marks is 30. Then I have in chemistry, let's say I have 56. And in maths, let's say I have 78, right? And then I have another entry, something like this here. And now these marks are of different people. So now this is, let's say, marks of Sumit. And let's say this is what I have to save. Now let's say I have many students, and for all these students I have to save this kind of data, right? Now this is, let's say, 90, this is 40, this is 28, right? Something like this. So this is the data for which a dual hash map is demanded, because you want to, actual information is this 30, 56, 78, right? But this data is associated with a key called as chemistry, physics, maths, and then this as a whole is associated with another key, right? So you need a dual hash map in this case, where you want to save two keys for this data, right? So if you want to get the access to 56, you need to mention that hash map dot akash dot chemistry, and then you will get 56, right? This is what the structure, let's say, you want to create. So I'll show you how to create this kind of structure. So let's say, let's see if we create this, I will, or rather let me show this in a separate method altogether, otherwise it will be confusing. So I'll write here public void p01 dual hash. I'll paste it here and mark this as embedded test, and I'll start creating it. So I'll write here string comma string. I'll write here child or Akash HashMap. Let's say I want to save in this Akash HashMap, new HashMap, string comma string. Rather, actually, this is supposed to be an integer. So I'll write here integer. And then in the Akash HashMap, I'm going to add this value. Akash HashMap dot put. So I'll write here Akash, and I'll write here my marks. So I'll write here, not Akash actually. I should have been writing. Let me rename it as Akash marks for more clarity. Right. So Akash marks, and my physics has, let's say, 30. And let me copy paste these. Chemistry has this, and maths has this. So this is 56, this is 78, for example, right? And then similar hash map I'll create for Sumit, and inside this I will write 90, I will write 46, I will write 28. All right, now what next which I want to do is I want to have a parent hash map, because I want to save all this data into a final, parent hash map. So what I'll do, I'll write here create another hash map. Now this will be my parent hash map. I'll write here hash map. Now hash map as string, and in the value part of this, I'm going to add another hash map. So I'll write here hash map string comma string hash map parent new hash map string comma hash map of string comma string. Sorry, it's not supposed to be here. Right, so my hash map is completed, right? Now inside this hash map, I can put another hash map, which is this. So first I'm going to add here that Akash marks are present here, and hm parent dot put Sumit marks are present here. Actually, I should have replaced it like this, comma, ArrayList. All right, now if I show you by running it, you'll see what I'm trying to say. So 1 minute, something not right. It was supposed to be integer, yeah, so I have to name it as integer, because in the YC, first let me explain this declaration. Hash map, so I want to create a parent hash map, right? And in that parent hash map, what I want is, I want the key value as the name, so this will be a string, and in the value part of it, I want to store another hash map, right? So that's why I've written string in the key, and in the value part of it, I am writing that I need another hash map in the value, and inside this we have string and integer. All right, I'll explain that in the same concept in a share also. Let me do that. So let me draw it first. So this is my parent hash map, okay, and inside this parent hash map I have, let's say, two sections. One is this, second is this, and inside this, let's say I have another subsegments, and inside this I have like 3 entries. Okay, now let me write here. So this is my Akash, this is key. Now inside, now this is my parent hash map, by the way. Now this is my parent hash map. Okay, and this is my, let's say, Sumit, right? So parent hash map have this key, right? This section is key, this is value, and in each of this element in the value section I have another hash map. So I have these child hash maps here, child hash maps, and you see these. This is where I have physics marks, this is I have chemistry, and this is where I have maths, and this is where I would keep the marks. So I'm putting here as, this is I have, let's say, 30. Here let's say I'm having 23, and let's say here I am having 56, right? Yeah, so this is how basically this data structure is created. So just to summarize again, this is a parent hash map, this is key, this is value, and each of the value part of each key we have another hash map which again has its own keys and values, right? So this is its keys PC, and these are its values, right? So let me share back the desktop Eclipse. This is what I've done. So first I'm creating the child hash maps. This is my Akash marks hash map. This is Sumit's mark hash map. Then I have a parent hash map. Inside each key, I have to add another hash map. So this is how I'm declaring it. Then inside I'm using HM parent. Then I'm putting, I am invoking a method put, and here I'm writing the key. And in the value part, I'm writing the hash map here. Right, so if I go and print this out, you will see, if I write here hash map dot toString, you will see how it will run. So let me run it again, run as JUnit test. So you see, this is my hash map here. Okay, now Akash, this is the key. Inside this key we have the value as this, and inside the value I have another hash map, right? Then in second element of hash map is Sumit, this is the key, and this is the value, and inside the value part I have another hash map, right? So this is how we achieve two-dimensional data. So this is how we achieve dual hash map implementation. So this is this declaration is important. Why I'm telling you this example is because this boosts your understanding of how to declare the hash maps, and you know, how to create you know, a list of hash maps, of lists. You know, the different combinations are available, and these all are important in our understanding of how we do, or how we do automation scenarios. These all are important. That's why I'm just talking about these basics first before we actually jump onto those situations and scenarios, right? So these basics are important. I would ask everyone to actually try this out in your systems. Just one last thing, which I still have to tell you, is how will you iterate a hash map. Now the way you iterate hash map is not entirely different than how we did in our ArrayList example. So let me just do that. Iterate a hash map. By the way, for your information, hash map is not an ordered list. So when you do, you know, when you do put, right, it doesn't matter that it doesn't mean that it will always save in a same sequence. It's not an ordered list. That means if you do this in ArrayList, it will always be ordered. The new element will be added at the bottom, but in hash map there is no guarantee. Okay, so you have to remember that this is not used for ordering purposes. Indexes can change. Now I was talking about iteration, so let me show you how that's done. So we can do that using for loop, right? So for, I mean, the way, I mean, there are many ways of how you can iterate it. I'm just telling you one of the way by which you can iterate a hash map. So let's say I want to iterate this hash map, right? So to do that, what I'll do, I'll create a for loop. Okay. Then inside for loop, what I'm going to write is, I'll write map dot entry, something like this. Okay, sorry. So I should write here map dot entry, and then here I should write string, and here I should write integer. Right? Why? Because that is what is the content of this hash map which I want to iterate. Then I will create a variable called as entry colon, and then I'll write here hash map, name of the hash map which I want to iterate, and inside this I'm going to invoke a method called as entry set. Right, so this is the condition. You have to remember it. How will you iterate it? How will you iterate a hash map? Right, so once you do this in the entry object, you're going to get two methods. So we are going to get two methods. One is entry dot get key. This will give you entry for a specific, this will give you the key value of that first element which you encounter while looping. And second is entry dot get value, right? So let me print these out as well. Sys out, this becomes my entry key. So I'll write here like this, key is, and maybe I'll also print the column, the value. Value is dot entry value, maybe this. All right, so what will happen for each iteration? For each iteration, it will convert that element of the hash map into an entry object, and inside that object, if you do get key, it will give you the key for that specific iteration. And when you do entry dot get value, you will get the value of that specific iteration. So if I go and run this, you will see key is A, value is 1. Second iteration, key is B, value is 2. Third iteration, key is C, value is 3. Right, so that is how also you can, I mean, there are many ways, as I said, there are many ways to iterate a hash map, but this is one of the way, and I think one of the most used way as well. Right, so yeah, so I have spent how much 1 hour in explaining ArrayList and HashMap. Try this at in your own local system, and we are going to use all these concepts in our actual automation framework while automating, live, or I should say real automation scenarios. Thanks.